Hello everyone and welcome to MV Tutors. My name is Tulu and we'll be looking at physics today, particularly the topic vertical projectile motion in one dimension. Before we begin with the theory, we're just going to look at the question we'll be answering. It's quite a simple question. It was actually from the 2016 November paper. But for those who want complicated questions, please do make an appointment with us and we'll help you with those. All right. So the question is as follows. A ball is dropped from the top of a building 20 meters high. Ignore the effects of air resistance. First question, define the term free fall. And then second question, calculate the speed at which the ball hits the ground, as well as the time it takes for the ball to reach the ground. And the last question, sketch a velocity time graph for the motion of the ball. No values required. Okay, so let's cover the theory. Firstly, what is a projectile? A projectile is an object. Okay, for example, a rock, a ball, or even a bullet. Okay, and since we're looking at vertical projectiles, we're going to look at the motion that is upward or downwards. Okay, and when we describe projectiles, we describe them using either displacement, velocity, and acceleration. Okay, and also the acceleration in the vertical, in most cases you'll have gravity acting on the projectile. Okay, and we know that gravity in metric, we're just going to simplify it as being equal to 9.81 meters per second squared. Okay, so what is displacement? Okay, so displacement. So basically, displacement is when an object is going from one place to another. Okay, so you have your projectile moving from one position to another. Okay, so I'm just going to say moving from one position to another. Moving from one position to another. Okay, and then we get to velocity. What would that be? So if I were to describe that motion from one position to the other, that's basically velocity. Factoring in time. If I move from A to B, okay, let's say A to B is 5 meters. If I now look at how long it took me to move from A to B, now we're looking at velocity. Okay, so basically displacement over a certain time. Okay, yeah, I think that's how I would best describe it. All right, so yeah, displacement at a certain time. Okay, and with displacement, we normally measure that in meters, but because now with velocity we want to know how fast or how slow we're moving, there's a time factor into it, so your unit would be meters per second. Okay, then we look at acceleration. All right, so acceleration is the change in velocity. So let's say you're walking a distance of 5 meters and it takes you 5 seconds. So each step is a second. So 1 meter per second, basically, that would be a velocity. If I were to look at acceleration, if I were to speed up, okay, that is the change in velocity. All right, if I were to slow down, which is deceleration, that is also a change in velocity. But if I'm always walking 1 meter per second, that is constant velocity. So whenever you have constant velocity, there is no acceleration. But the definition of acceleration is the change in velocity. Okay. So the change in velocity over a certain time. over a certain time. Okay, and again it will be meters per second squared. I think in metric you're supposed to say meters per second like that, and meters. Okay, and then with regards to projectile motion, there are 4 scenarios, okay, in which where we can describe projectile motion. Okay, and the first scenario that we can look at is if you just drop a ball, okay, or dropping your projectile. I'm just going to use a ball in these examples. So if I drop a ball, okay, that's the first scenario. We're going to discuss it at length. But basically, if you drop an object, you're not applying an initial velocity, okay? So your initial velocity there will be 0, all right? And its maximum velocity will be reached once it touches the ground, okay? So just looking at dropping the ball, all right? A second scenario is if you throw a projectile upwards. Throw a projectile upwards, okay? And what would then happen? You throw it from its initial position, and it throw it up in its initial position, and it goes and drops at its initial position, okay? So the start and end elevation are the same, okay? And then another scenario when you throw a projectile upwards is that maybe you are standing on a high platform. So you throw it up, and then instead of it coming to the point where you threw it, it actually goes further below. Okay, so that is where its start and end elevation are different. Okay, they are different. So basically here you start there and you end in the same position, but here you start somewhere and then it drops further. All right, here you're just dropping the ball, so it goes all the way down. All right, and then the third scenario is when you have a ball or projectile that bounces. Okay, here let's just stick to a ball because a stone doesn't bounce. Well, it can bounce depending on how much of a force you used initially. Okay, so you have a bouncing projectile. Okay, so whether you dropped it, okay, it could have dropped and then bounced. Oh, snap. Why did it do that? Okay, so you could have dropped it and it went down and then up again. Okay, or you could have thrown it up in the air and it went down and then bounced, and as you can see, each time it bounces, okay, it's not at the same height anymore, and we'll also discuss that because it keeps losing energy. But yeah, we'll address that now. Okay, another thing when dealing with vertical projectile motion, you need to decide from the onset which direction you will take as positive. Okay, so let's say you're gonna choose downwards as positive. Okay, if you do that, state it in your tests or exam or wherever the marker will see. And if you are saying downwards is positive, just make sure all your questions follow that. Okay, so if downwards is positive, remember gravitational acceleration always acts downwards. Okay, so in this case you will have a positive gravitational acceleration. All right, and if you choose upward as positive, because gravity is always acting down, in this case, gravity will be negative. So while you're doing your calculations, please choose, is downwards going to be positive or is upwards going to be positive, and then go on as you chose. All right. So let us look into detail these scenarios. What happens when you actually drop a ball? Okay. So looking at scenario number 1, you're dropping your projectile. Okay, and what if you choose downwards as positive? And what if you choose upwards as positive? Another thing is, when you're doing the importance of understanding all this theory is when you apply it as well, you should be able to draw graphs, okay, indicate a time displacement graph or a velocity time graph or acceleration time graph. It's very important that you understand and even perform calculations looking at graphs. All right. Okay, cool. All right. So if you drop a projectile, your initial velocity, because you're just dropping it, is going to be 0. Okay. For both scenarios. 0 meters per second. Okay. All right. And then what about your final velocity? Well, your final velocity, which is actually your maximum velocity as it touches the ground, that value will be something. Okay, it'll be something meters per second. But for the projectile that falls, or the direction, if you chose positive as downwards, then your final velocity will be a positive as well. Okay, because it is going downwards, right? But if you chose upwards as positive, okay, your final velocity will be a negative value if you chose up as positive. Now, like I said, with gravitational acceleration, because gravity is always going down, you will have a positive 9,8 meters per second squared. But here, because you chose up as positive, it'll be negative. All right, and then your displacement. Okay, so y, we're not using x because x is in the horizontal, we're using y because it's in the vertical. If you chose downwards as positive, then your value here will be positive. If you chose upwards as positive, your value there will be negative. Am I missing anything? No. And time, well, time is a scalar quantity, so yeah, time is just time. It's always positive. You never really get negative time. Okay, now when it comes to your graphs, you have your position time graph or your displacement time graph. Okay, another thing, all these your displacement, velocity, and acceleration, they are vectors, so they have both magnitude and direction. Okay, so you should indicate it as such. Okay, so yeah, let me just do it like this. So a displacement time graph, okay, let me just start it again. Okay, so if you chose downwards as positive, your displacement with regard to time, it'll be positive, right? So it's going up. Okay, on the graph, sorry, your projectile is falling, but yeah, this is the direction. And then if you chose upwards as positive, well, it will go like that. Okay, now when we look at velocity, okay, with our velocity, if you chose downwards is positive, your initial velocity, because you're dropping it, it will be 0, right? And then it will increase, okay, with time. So that is velocity, and that is time. Okay, that's if you chose downwards as positive. But if you chose upward as positive, okay, that will be different. Your initial velocity will be 0, okay, but because it's in the opposite direction, it will increase, but it will be in the opposite direction there. So that's time, and that's velocity. Okay, if we look at acceleration, if you chose downward as positive, okay, because acceleration is positive in a downwards direction, and gravitational, remember the only force acting on this projectile, because you dropped it, the force acting on it is gravitational force. This is like a free fall, okay, and that's one of the questions in the exam, defining what free fall is. We'll leave that for the exam question. Again, acceleration is a vector, okay, and that will be 9.8, okay. And if you chose upward as positive, okay, okay, so you'll have negative 9.8. Yeah, so that is how you would relate with a dropping of a projectile. Remember, when you drop a projectile, the only force acting on it, gravitational acceleration. You decide is downwards positive or upwards positive. Once you've decided, stick to your decision. Okay, and then now let's go to the second scenario. I would call it as 2A, okay, where you throw your projectile up and it lands at the same elevation. Alright, so if we're looking at a projectile that was projected upwards and then it ends up on the same elevation, taking into account that I always like choosing downwards as positive, but I will look at both scenarios. So this is downwards as positive. So what happens if you project it upwards? You do have an initial velocity, right? So there is an initial velocity. And because that initial velocity is taken upwards, okay, in this case, then you'll have an initial velocity that is negative. All right. And then you get to this point here where it reaches its maximum. Okay, when it reaches its maximum, which is your final velocity, it is 0, okay, because it can't go back downwards if it didn't stop at some point. So you throw it up and then it stops at a certain point and it goes down again. So your final velocity there is 0, and then this is the upward motion, right? Then your downward motion, you have your initial velocity as 0, okay, and then when it comes down here, it'll be your final velocity, which is your maximum velocity, and that will be a positive value. One thing to note is that this initial velocity will be the same as this final velocity. The only difference is the signs involved. Okay, now if we look at the displacement, okay, your delta y in this case, it'll be negative because, yeah, thrown up, but you chose downwards as positive. Okay, so it will be negative, whatever, all right? And then if you're going to take the downwards side, okay, your displacement there is going to be positive. Okay, and there's one thing to also observe is that the time that it takes to go up will be the time that it takes to go down. All right, yeah, And that's it. So I'm just going to pause now and show you what happens if you chose upwards as positive. Okay, so basically if you took up as positive, the signs change, but everything else remains the same. The concept is the same. If you were out of interest, if you were to draw the velocity time graph, this is really basically showing you the displacement time graph. But if you were to draw the velocity time graph, okay, you would have your initial velocity, right? If you took downwards as positive, just gonna squeeze it in here. If you took downwards as positive, so initially it's going up, okay? So it has an initial velocity, but it's negative because you chose downwards as positive. And then as it goes up there, it decreases. The velocity decreases as it goes up, okay? Because now, remember, there's gravitational acceleration acting on it. So your projectile is going up, but gravity is sort of pulling it down. So therefore, it loses its velocity until it gets, oh gosh, let me do it this way. Let me just start again. Sorry about that. Okay. So it starts wherever it starts, right? I'm just going to align it with this, okay? And then it reaches its maximum here, maximum displacement, but maximum displacement means 0 for velocity. So it's somewhere there, and then again it goes down. So downwards we took as positive, so it should be there on the positive side. Okay, and it will reach its maximum. And these values here, let's say you had initial velocity of 5, it should also be 5 there, its maximum. Okay, and then you'll have a straight line looking something like that. So yeah, I tried. Okay, now we're gonna look at scenario 2B. Okay, so now we have the second scenario, part B, where a projectile is projected upwards and falls below the initial level. Okay, I've chosen downwards as positive. So when you apply your initial velocity, which is going up, okay, but here because I chose downwards as positive, my initial velocity again will be a negative. Okay, when I get to my final velocity, because the velocity decreases as the projectile goes upwards because of gravitational acceleration, it will reach 0 at the maximum. Okay, and then that's just the upward motion. The downward motion, okay, I'm going to have my initial velocity as 0 as well. All right, and then once I get here, the velocity there, it's not a maximum because this projectile is still moving down. So this velocity there, it will be a positive, okay? And it will actually be equal to the initial velocity. Okay. And then the projectile still is going down until it reaches the ground level. And at this point, that is where you have your maximum velocity. All right, and it is a positive. All right, so again, the time it took for it to go up, okay, let's say this is A, B, C, and D. The time it took for it to go from A to B will be equal to the time it took for it to go from B to C. All right, and if you want to know the time it took for it to go to C, from C to D, you'd have to calculate that extra. Okay, and again, the displacement, because we took downwards as positive, this side will be negative, and the displacement, this side, that will be positive. Am I writing? Okay, so the displacement there will be a positive value, and that is what happens there. All right, if you want to take upwards as positive, basically all these values will be negative. Then looking at the last scenario where you have a bouncing projectile, okay, Just gonna draw that up quickly and we'll discuss. Okay guys, so when we have a bouncing projectile, so let's just say it bounces from the ground, okay? I'm not gonna indicate the scenario where you drop it and then it starts bouncing, or where you throw it and then it starts bouncing. We're just gonna take it from it's at the ground and then it's gonna bounce up until it reaches ground again and bounce again. So just 2 bounces. Okay, so here we are, the displacement is 0, then it bounces all the way up, reaches its maximum height, goes down, and at this point here in between C and D, that is when it is in contact with the ground. Okay, so there's a little bit of a space there, and then it bounces again up, and then you'll see that the height of the first bounce is greater than the height of the second bounce, because once it gets in contact with the ground, okay, remember it's quite inelastic in that region, C and D. So it loses some of its kinetic energy once it gets into contact with the ground. Okay. And then when this ball exerts a force on the ground also exerts an equal but opposite, okay, force on the ball, which propels it upward again. But because it lost that energy there between C and D, the bounce is much less. The height of the ball is much less, and it goes on and on until it eventually reaches rest. Okay, so what will happen to the velocity then in this case? Well, we know that where the ball reaches its maximum height, that is where velocity is 0. Okay, so we know that the velocity is 0 here, and again we're expecting velocity to be 0 there, but since we have taken upward as positive, okay, we know that the velocity there will start as positive as well. So point A, whatever the velocity is there, and then it will, okay, see, the starting position and the end position is the same. So the velocity, initial velocity, okay, will be the same as the maximum velocity. All right, so that's C. Actually, I should end it here at C. It's quite important to note that. So yeah, this is B and that's C. So the velocity at A is equal to the velocity at C, and the velocity at C, that is your maximum velocity, that is your initial velocity there at A. All right, now there is that point of contact with the ground, okay, and then again you have an initial velocity there at D, which is much less than A, and it passes through E, and then it ends up at F. Okay, no, what am I doing? Okay, so it ends up somewhere just above C because it's less. Okay, so I'm not drawing this to scale, that's why it looks a bit funny, but yeah. And yeah, so basically that's your initial velocity for the first bounce, and then the maximum velocity for the first bounce. Then you have that contact with the ground between C and D. You can indicate it by using dotted lines, or you can just leave it. Okay, it's up to you. And then again, the second bounce, initial velocity there at D, and then the maximum velocity there at F. And then at G, we know that velocity is 0. So that is your velocity time graph. Maybe let me make it black so that it is quite visible. So yeah, it is something like that. And then like that. Okay, and you can decide to make this dotted or leave it. All right. And then for acceleration, so we know that in the vertical direction you have a constant acceleration, right? Gravitational acceleration, which is acting downwards. Since we chose upwards as positive, it means we're gonna have our negative Okay, so I'm just gonna draw dotted lines here before I draw my actual graph. Okay, and then what I want us to consider is the time of contact with the ground. So between C and D, I'm just also gonna have dotted lines there, because something happens to the acceleration when the ball is in contact, or the projectile is in contact with the ground. Okay, so yes, throughout the motion, when the ball goes up and down, you have constant gravitational acceleration. And again, when it bounces, you have constant acceleration, gravitational acceleration. Okay, but what happens when it's in contact with the ground? Okay, so the gravitational acceleration, acceleration will do something like that. It will spike upwards. Okay, and that is because of the contact it has with the ground. So we know that gravitational acceleration is constantly downwards, but the ground exerts a force on the ball in the upward direction. Okay, so gravitational acceleration is downwards, hence the negative side, but that upwards part with that contact with the ball, it propels the ball upwards. It's the energy required to make the ball bounce from the ground upwards. Okay, that's why we have that spike there. And actually, an interesting fact that I learned, for us to get velocity, okay, velocity is the change in displacement over the change in time. When we want acceleration, that is actually the change in velocity over the change in time. Okay, that is meters per second squared, and that is meters per second. It doesn't end there. Although for high school it's you end at acceleration, there is actually something where you have a change in acceleration over the change in time, and that is called a jerk. Okay, not a jerk as in like, oh, that bird or that guy is such a jerk. No, the jerking movement where, yeah, that is like your change in acceleration. Think, for example, a first-time driver who the car keeps switching off, and when it switches off, it has that jerking movement. So jerk is change in acceleration over change in time, and the unit for that is meters per cubed seconds. And it goes on and on and on. Actually, after jerk, there's this thing called snap, okay, which that would be meters per seconds to the fourth power. And then you have crackle, which is meters per second to the fifth power. And then you have pop. Does that remind you of something? Yes, Rice Krispies, Snap, Crackle, and Pop. That's actually where they took it from. It's quite interesting. Not really for examination purposes, I just thought I would share. And okay, so we've covered basically all the scenarios. The most important part now is when you do calculations, you're going to use the equations of motion. But these equations of motion are going to be for the vertical direction, okay? I'm just going to write them down quickly. Okay, so these are the equations of motion, all right? And then, like, this is so important where you decide whether you're going to take upwards as positive or downwards as positive, because it affects your acceleration, okay? Remember, if you're going to take downwards as positive, then your gravitational acceleration will be positive 9.8 meters per second squared. It also affects your displacement, okay? If you're going to take downwards as positive, your displacement will be positive, but yeah, it really does depend, okay, just as we have discussed before. So be very careful and be very mindful of your signs depending on the direction that you took, okay? And now we're going to look at the question initially and just answer those questions. Okay, so we're going to answer the first question, which says define the term free fall. Okay, and I said I'd leave the definition for this question. So basically, free fall free fall means there is unimpeded motion. Okay, there's no disturbance to your falling, is free. So first of all, your motion is unimpeded. Okay, meaning there's nothing external that's affecting. Unimpeded. Okay, am I spelling it right? Yes, I am. Motion that is unimpeded. Okay, and also we do not take air resistance into account. Like we said, ignore the effects of air resistance. Okay, so don't take air resistance into account. All right, and it's amazing that in the absence of air resistance, if you were to drop a feather and also drop a bar of gold, both of them are going to reach the bottom of or they'll reach the ground at the same time. Okay, because in that point, when you look at projectile motion, you don't consider the mass of an object. Okay, in free fall, you're really just considering what's acting on it, which is just gravitational acceleration. And both of them, regardless of their mass, they will reach the ground at the same time. So the third thing is the motion is unimpeded. There's nothing affecting it externally. You don't take air resistance into account, and the only force acting on it is gravitational acceleration. So gravitational acceleration is what acts on it. Gravitational acceleration acts on the projectile. Or rather, it is affected only by gravitational acceleration. Okay, now let us calculate the speed at which the ball hits the ground. Okay, that is where we now look at our equations of motion. So this ball was dropped. Okay, because it was dropped, oh, what are we taking as positive? I like taking downwards as positive. Okay, so because it was dropped, my initial velocity is going to be 0 meters per second. Okay, my displacement is going to be positive 20 meters, and my gravitational acceleration will be positive 9.8 meters per second squared. Now I need to go look at my equations of motion and see which is applicable. Okay, and what am I looking for? I am looking for the speed at which it hits the ground, okay, which is like my maximum velocity. So that is what I am looking for. And if I look at these equations, I can't take this first one because it requires time. We were not given the time it takes. Yeah, I can definitely use this one because my unknown here is just the final velocity. So let's do this. Okay, so final velocity squared is equal to initial velocity squared plus 2a delta y. Okay, my initial velocity is 0. Okay, then gravitational acceleration is positive, and I have positive 20 there. So my final velocity will actually be everything else that is rooted. Okay, let's use the calculator. Okay, so under the square root I have 0 plus 2 times 9,8 times 20. All right, why is it giving me values like that? Okay. All right, what is happening? Okay, so it's 14 root 2. Let me just get the final answer proper. All right, so 14 root 2 is just 19,8 meters per second. And the second question they asked is for us to calculate, I think, the time it takes for the ball to reach the ground. So we have the final velocity, we have the initial velocity, we have our displacement. So we can either use this equation, because we're looking for time, or that equation. But I would caution a bit. I wouldn't use the first equation because that is you assuming that your final velocity is correct. Okay, and if your final velocity was wrong, you'll be carrying forward a wrong value, which will give you the wrong time. So I would rather use an equation that is independent of a previous calculation. So I'm going to use this one, the last one. Delta y is equal to initial velocity times t plus half acceleration t squared. Okay. Initial velocity times t plus half acceleration delta t squared. Yeah, I hope I got the right equation. Yes. All right, so we know that is 20 because we took downwards as positive. Our initial velocity is 0. And then we have half. Acceleration is positive 9,8 and t squared. So I am going to rearrange this a bit. I have t squared is equal to 20 over 9,8 divided by 2. I think that's 4,9. And then t is just the root of that. So how long did it take? Okay, we have 20 over 4,9. Oh gosh, why is it giving me answers like this? Okay, if I'm just going to check it quickly on the calculator, it's going to give me 2,02 seconds. Okay, yeah. And then the last question says, sketch a velocity time graph for the motion of the ball. Okay, so basically, okay, so we have our velocity, we have time. So this had an initial velocity of 0. Okay, and we are taking downwards as positive. Okay, it was dropped, so it will ultimately, its maximum velocity will be positive, and we found that the maximum velocity is 19,8. Okay, they said no values are necessary. Okay, so we don't have to put it, but I will. We know that at 2,02 seconds we had a velocity of 19,8. Okay, all right. And interestingly enough, I know we're done, I've taken so long, but I have to share this. If you wanted the displacement, you can use your velocity time graph and you can take the area below your velocity time graph. So basically, the area here. Okay. All right. If you wanted the displacement, just take the area below. It's a triangle, so it's half 2,02. That's the base, and the height is 19,8. And yeah, guys, you should be able to get 20 meters, right? So yeah, if you have 0,5 times 2,02 times 19,8. Okay, guys, what is my calculator doing? Just going to use my hand calculator. So 999 divided by 500. That is 19. Let me remove this. I'll fix my calculator. It is 19,998. Because these values are rounded off, of course it will be that. But if I round that off, that is 20 meters. So if ever you have your velocity time graph and they ask you for they ask you for the displacement, and you forgot how to apply your equations of motion, you can take the area under the velocity time graph and you will get your displacement. Alright guys, that concludes the lesson for today. Don't forget to like this video, subscribe to our channel. If you want to make bookings, please do visit www.mvtutors.com, okay, to make a booking for a tutorial session. And yeah, we'll help you with those hectic ones, like what do you do when you have a bouncing ball or whatever. We'll be glad to assist you. Okay, thank you. Bye.